In this video, we are asked to prove sine to the 4x minus cosine to the 4x, all divided by sine to the 3x minus cosine to the 3x, equals sine x plus cosine x, all divided by 1 plus sine x cosine x. To carry out this proof, we'll need two expressions from algebra. And those are the difference of squares. Difference of squares says a square minus b square equals a minus b multiplied by a plus b. And then we'll also need the difference of cubes. Difference of cubes says a cube minus b cube equals a minus b multiplied by a square plus ab plus b squared. I will use these expressions to manipulate what we have on the left hand side of this proof to obtain what we have on the right hand side. So firstly, I'll start with the numerator. On the numerator, we have sine to the 4x minus cosine to 4x, all this divided by sine cube x minus cosine cube x. You can now express that as sine square x all squared minus cosine square x all squared, and still have what we have on the denominator. Now we've been able to simplify the numerator into what is called a difference of squares. Originally, it was a difference of quadrics, but we can simplify that to a difference of squares. And now we have the numerator in terms of a squared minus b squared over here. And so, still working on the numerator, we can now say that sine square x minus cosine square x, and here we have sine square x plus cosine square x. We still keep the denominator the same. We'll come back to the denominator later on. This is sine cube x minus cosine cube x. From trigonometry, our Pythagorean identities, we can conclude that this here is 1. So it's the same as saying 1 times sine square x minus cosine square x. Now, still on the numerator, sine square x minus cosine square x is also a difference of squares. So we can express that again, but this time as sine x minus cosine x multiplied by sine x plus cosine x. And that's for our numerator. For the denominator, to still be the same. At this point, I think we are done with the numerator, and can now manipulate what we have in the denominator. So our denominator is a difference of cubes because of the 3 we have there. So we can use our difference of cubes over here and simplify that such that we can have on the numerator sine x minus cosine x multiplied by sine x plus cosine x, then all this divided by sine x minus cosine x multiplied by sine square x plus sine x cosine x plus cosine square x. You see that this here and this here cancel out, and it cancels out because this quantity here is 1 and this quantity here is 1 and it's being multiplied by the other quantity next to it. If they were added, the cancellation wouldn't work out. But because this quantity is 1 and there's another quantity again and they are the same, they will cancel out. And so at the numerator we have just sine x plus cosine x, and the denominator we have sine square x plus cosine square x plus sine x cosine x. Now from our Pythagorean identities, this here is equal to 1. And as such, we can now say that in the numerator we have sine x plus cosine x divided by 1 plus sine x cosine x. That is our final proof.